All right, hello physical science students. This is Austin Marquis with your second lesson on electricity. If you haven't watched Mr. Olaf's lesson, go back and do that. There's going to be some important information you're going to need to know in that. But we are going to do a short review and then go over Ohm's Law. So let's get going on that. So first off, what is Ohm's Law? First off, get something to write with. This is something you're going to want to write down. Make sure you write this down. It is V equals IR. We're going to go over kind of a little bit more about what that is. But as a short recap here, Mr. Olaf went over those in his lesson. But to start off, V, or this V in your V equals IR, is voltage. And that's going to be like the pressure of the electricity, or something that like pushes the electricity through a circuit or a wire or something like that. Next, you're going to have I. I is the current. It is the flow or amount of electrons that move through a wire or a circuit. R is going to be resistance, and it's measured with this little horseshoe shape, the omega shape, and that is actually ohms. But that is something that you put in a circuit that slows down the current in a circuit. And you're going to want some sort of a resistance in your circuit. Otherwise, you end up like burning up your battery. So V equals IR. This is Ohm's law. Now, this V is for voltage, and that is measured in volts. That's kind of an easy one. The next is I, that is current, and that is measured in amps. R is resistance, and that is measured in ohms. You also see the little horseshoe shape, or omega. That would mean resistance whenever you see that. Now, on the next several slides, there's going to be some pictures of some circuits. I'm going to just start going through some practice problems. Follow along with me. That's kind of, I think, going to be the best way to teach you guys how this works. But for all of these, we're going to use Ohm's law. So V equals IR. Okay, so using Ohm's law in a series circuit. This is going to be a picture of our series circuit. You see this thing right here, this big line and this little line? This would mean that this is a battery. And it says that this is a 10-volt battery. Now, this line here, this is the wire. And then you'll see this squiggle over here. Anytime you see a squiggle, that represents resistance. Now, in this case, we have a 10-volt battery, and it says that our current that is moving through our wire, or I, is 2 amps. Now, we know V and we know I, and we look down here in R, it says that we have a resistor, but we don't know what the resistance is. Well, just in any Ohm's law equation, V equals IR, if we know 2 of these things, we can solve for the third one. So we have to know 2. If you only know one of them, it's no good to you. You have to be able to know 2. So we start plugging in, what do we know? Well, we know that volts is 10, so that's V, and I, or current, that is amps, that is 2.0. So we plug this in. Volts equals 2 amps times resistance. Now, we don't know what resistance is, it says question mark, so we're just going to leave that as an R. Now, with this, we're going to divide this side of our equation by 2, and it means we have to divide the other side by 2. Now, when you do that, that cancels out, and that gets R all by itself, and your equation will end up looking like this. We've divided 2 by both sides, 2 cancels on the right, leaving it on the left on the bottom. So 10 volts divided by 2 amps will give you your resistance. Pull out your handy dandy calculator, and you will find that if you have a 10-volt battery and there is 2 amps of current running through that wire, then your resistance must be 5 ohms. This is a 5 ohm resistor. Now, we're going to go on. We're going to solve a couple different things. You can solve for other things other than R. Now, really similar circuit here, except this time you'll see we don't know what V is. So V, that's question mark. We start plugging in. What do we know? V equals IR. V is question mark, so we're going to leave that as V. I is 3 amps. R is 10 ohms. We plug that in. This is what it'll look like. 3 amps times 10 ohms. And that means that this will have to be a 30 volt 30 volt battery. Now, with something like this, maybe you have a wire and you say, hey, I know I want 3 amps moving through it. I have a 10 ohm resistor. What must my voltage of my battery be if I do want 3 amps moving through my wire? So, working on Ohm's law. All right, moving on. All right, another series circuit. Now this time we don't know I. We don't know what the current is. We know that we have a 12 volt battery. We know that we have a 15 ohm resistor. And we just plug in what we know. 12 volts is going to equal the current, which is I. Leave it as I because we don't know what it is. That's a I, not a 1. And 15 ohms as our resistance. We divide the right side by 15. Divide 15 on the left side. The right side will cancel. We get 12 volts divided by 15 ohms will give us our current. Pull out your calculator again for that, or use your phone. And I will equal 0.8 amps. So that will be the current moving through this wire. All right, now we're going to go a little bit more complicated on these next couple, but still won't be too bad. Okay, so now we have multiple resistors in our series circuit. Now remember, in a series circuit, you only have one path for the electrons to go. The current will only be moving in one direction. Now, that means the current will leave the battery, and it has to go through both resistors. Because of that, we can add up these resistors and say that we know this one's 5 and this one's 10. We can add them up and sort of like just pretend and say, hey, that's a 15 ohm resistor because there is only one path. Now, just again, start plugging these things in. That resistor trick where we add them, that only works on a series circuit. Don't try to add them when we do a parallel circuit. And we will work a little bit with the parallel circuit next. Anyway, to find out how much current is moving through this wire, we are going to, again, use Ohm's law, but we have to add these resistors together because it is a series circuit. We can do that. Now, voltage is going to be 30 volts. Leave I by itself because we don't know what the current is. We don't know how many amps are moving through that wire just yet. And we add these two resistors together. 5 plus 10 will give me a total of 15 ohms of resistance. So I can say my R is 15 ohms. Now we divide the right side by 15, divide the left side by 15. Right side will cancel. You'll end up with an equation that looks like this. 30 divided by 15 is going to equal I, or current. And your current will be 2 amps. 30 volts divided by 15 ohms equals 2 amps. That is how much current is running through this wire. Okay, now working with a parallel circuit, that could be a little bit different. So what happens in a parallel circuit, the current will leave the battery and it will get to this little junction right here. It'll get to the spot where now it can either go straight or turn right. And some current will go through both, but you can see that both of these are going to have, both of these different paths both have resistors on them. So current is going to go through both of them. But because the resistance is different, the current will also be different. So to start off, let's start with just current 1. I've got this I1 right here. That just means the current that's going through the first resistor, the 4 ohm resistor. Now we're just going to use Ohm's law with just this part right here. Now to figure out how much current is going down this wire, we start plugging things into Ohm's law. Now don't worry about this 6 over here. Don't worry about this second I or the second current that's happening over here. We'll get to that in a second. Right now, we're just worried about this part. And this 12 volts over here is also going to be useful. So we know that we start with 12 volts over here for our battery. We know we have 4 ohms of resistance. Now, to find the current, we plug these in. And this I, this current coming down here, is going to be the 12 volts divided by the 4 ohms. And the current moving through this part of the wire is going to be 3 amps. We're going to remember that. This I1 is 3 amps of current moving down the first junction here. Now, let's work on the second part. So for the second one, we know that this first part had 3 amps. Now, we're going to forget that. We're going to move over here. Again, we're using Ohm's law. We know that we start with 12 volts. The electricity will come up, and it will hit this junction. Some will go straight, some will turn right. Now, we know 3 amps will turn right and go down, but how much goes straight? How much current is moving through this part of the wire over here? Well, to figure that out, we plug in what we know. We know that 12 volts is going to be V, and we don't know what I is. That's the part that we're trying to figure out. What is the current? But R is going to be 6 ohms. Now, 12 divided by 6, getting I by itself, just some basic algebra there. But the current is going to be the 12 volts divided by the 6 ohms, telling us that, hey, there are 2 amps of current going through over here. Okay, so skipping forward here, we know 3 amps are going down this one, and 2 amps are going down this other one. Now, I like to do the does this make sense test. Does it work? I mean, yeah, they're different resistors, but should they have different currents also? Yeah, they would. That makes sense. But should 4 have more current moving through it than 6? Yeah, it would. It would because there's less resistance. Because there's less resistance, more current will move through that wire. The more resistance over here, the less current would move through the wire. The electricity is going to take the path of least resistance. Because this resistor is less, 4 is less than 6, more current will move through this part of the wire. Now, to find the total current, like how much current is moving through like this part up here, like right as it leaves the battery, all we have to do is add up these currents. Your I total or current total is going to be 3 amps. Oops, that's an equal sign. We'll say that's a plus. I bet I could change that. Plus, it's a terrible looking plus, but we're going to stick with it. 3 amps plus 2 amps is going to give us 5 amps of electricity. The current will be 5 moving through this first part of the wire. Okay, guys, I know that's kind of a lot of math. Ohm's law can be kind of a tough one, especially when we get into some parallel circuit stuff. But please go back and watch any of this again. Forgive me if I made a mistake. There's a lot of numbers I threw at you right there. But I'll go back, watch it, and see if I can't fix any of that. But yeah, check Google Classroom. Make sure that you are taking good notes. Make sure that you get those assignments done on time. If you have any questions, please email. Please join office hours, whatever we can do to help. but just let us know. And right on, physical science. Nice job. I will talk to you guys later.